The operations presented in this video are meant to be instructional to ensure quality construction. This video is not intended to provide a comprehensive overview of safety procedures. All parties should ensure that they are familiar with and follow all safety requirements, policies, and procedures that apply to their specific operation. This video discusses the important steps necessary prior to placing a concrete bridge deck. While there are many factors in the final deck construction, for the purposes of this video, we will begin after the beams have been set into place and fall protection has been installed. Once beams have been set, the first step is to install formwork for placing the deck concrete. Deck pans are stay-in-place forms which support the concrete in the space between beams. Setting the deck pans is critical, since the pan determines the actual bottom elevation and overall thickness of the bridge deck. If improperly installed, too much or too little concrete will be deposited on the deck, which could affect load rating of the beams and overall bridge design. Approved shop drawings for deck pans must be on the project before they are installed. Upon delivery, verify that the deck pans match the shop drawings in type, thickness, and the manufacturer. Certifications should also be reviewed for completeness and accuracy. Once the beams have been set, the contractor's surveyors will obtain elevations at 10-foot intervals on each beam. These elevations will be entered into a computer program which accounts for finished grade elevation, unloaded beam camber, and loaded beam camber. The output of the program gives the contractor measurements to follow when setting the support angles for the deck pans. A copy of the contractor's computer output should be obtained and reviewed by the inspection staff prior to installing the deck pan support angles. For example, for beam number 4 at station 170 plus 00, the bottom of the pan should set 0.11 feet below the left side of the beam and 0.07 feet below the right side. The contractor's surveyors will then place grades on each side of the beam for setting the angles. It is very important to communicate with the surveyors to understand what these grades represent. Some surveyors will list the fill height to finished grade, while others may show the grade to the top or even the bottom of the pan. Measurements are best checked by the inspection staff when the layout is being performed prior to welding the support angles in place. The welder's certifications should be checked by the inspection staff prior to any field welding being performed. Certifications can be checked at the American Welding Society's website. Copies of the certification should be maintained in the project records. The approved shop drawings should be reviewed for all installation details. Ensure the deck pans are lapped in the direction of the pour and secured in place as directed. After all the pans have been placed, all openings around the pans and formwork should be sealed to prevent leakage of grout during the deck placement. Gaps in the pans and formwork are easily identified from under the structure. Look for areas where daylight is visible. Now that we have discussed proper deck pan placement, we will focus on false work. The deck overhang is a temporary working area to be utilized during the deck construction operations and is installed concurrently with the deck pans. The contractor is to submit a false work design, prepared by a professional engineer, for the deck overhang. The false work design is to be reviewed and approved by the structure control engineer prior to installation. The false work is designed to carry the weight of the concrete, finishing machine, and workers. The false work should be inspected as it is being constructed to ensure it meets the design requirements. Prior to placing any concrete on the deck surface, the false work must be inspected and certified by a professional engineer. After the deck pans and false work have been completed, the placement of reinforcing steel can begin. Reinforcing steel should be inspected upon delivery for proper certifications, approved suppliers, damage, coatings, and grade of steel. Handling of epoxy-coated steel should be performed using nylon slings or other methods to prevent damage to the coatings. Reinforcement should be stored on platforms off the ground and should be free from dirt, oil, grease, injurious corrosion, or other foreign substances. Any epoxy-coated reinforcing steel that will be stored for longer than 2 months must be covered with opaque polyethylene sheeting to protect the coating from ultraviolet light. Galvanized reinforcement must be protected in the same manner if being stored for longer than 1 month. Mechanical splices are used to connect pieces of reinforcing steel to allow load transfer from one piece of steel through the next member. Mechanical splices are typically used for phased construction, when only half of a member can be constructed. The second half of the splice is manually installed after the change in construction phasing. Any mechanical splice systems to be used on the project must be sampled, assembled according to the manufacturer's recommendations, and tested by PennDOT's laboratory testing section prior to use. Samples of 4 increments for each size and type of mechanical splice must be submitted. 3 samples are to be assembled for testing to verify the physical properties, and 1 sample is to remain unassembled for testing of coating thickness on an epoxy-coated or galvanized coupler body. A copy of the manufacturer's assembly recommendations must accompany the samples submitted. Passing test results must be obtained prior to encasing the mechanical splices in concrete. It is important to submit samples early enough to allow time for testing and potential follow-up actions that may be required. The reinforcement is best inspected as it is placed, rather than once completed, to avoid any costly rework and hard feelings between the contractor and the inspection staff. For support, reinforcing bars are set on chairs. Typically 1-inch chairs are placed on the deck pans for supporting the bottom mat. The chair spacing is not to exceed 3 feet to prevent any unwanted movement of the reinforcement. All reinforcement is to be spliced and lapped as indicated, and is to conform to the spacing and clearances shown on the design drawings within plus or minus 1/4 inch. All bars are to be securely fastened at each intersection on the top mat. For other intersections, when the bar spacing is greater than or equal to 12 inches, tie all intersections. When the bar spacing is less than 12 inches, either tie all intersections or tie alternate intersections in each direction to provide a staggered tie layout. Tie epoxy-coated bars with epoxy-coated iron annealed wire, and tie galvanized bars with galvanized iron annealed wire. After all reinforcing steel has been placed and tied, the top mat should be tied down to the superstructure at sufficient locations to prevent any uplift during the concrete placement. Visual observations can be made for any obvious high or low areas in the deck steel. A 2-part epoxy touch-up kit should be used to repair any damaged epoxy coating. A780 zinc paint should be used to touch up any damaged galvanized coatings. Epoxy-colored spray paint is not acceptable. It's important to plan well to achieve quality in a bridge deck. At least 2 weeks prior to the anticipated deck placement date, a deck placement plan is to be submitted to PennDOT for review and approval. The plan must be approved by the structure control engineer. The minimum requirements of the plan are covered in the Project Office Manual, Part C, Section 10, page 8. Every aspect of the placement should be covered in the plan. A deck pre-placement meeting is also required at least 2 weeks prior to the deck placement. This meeting should include all parties involved with the placement, including inspection staff, the contractor's superintendent, foreman, technicians, district structure control engineer, quality assurance, district materials representative, and the concrete supplier's representative. All aspects of the deck placement should be reviewed in detail. Guidelines for the pre-placement meetings can be found in the Project Office Manual, Part C, Section 10, page 10. Now that the deck steel has been tied and the planning has occurred, we can set up the finishing machine that will be used to place the deck. The finishing machine will run on screed pipes. Screed pipes should be supported on cups, spaced at 24 inches, that nearly follow the same camber as the beams. There should be no dips or humps other than the camber of the beam. Any irregularities in the screed pipe should be brought to the contractor's attention. It is recommended that the screed pipes extend far enough beyond the structure to accommodate the work bridges and to allow the finishing machine to finish the entire deck in the skew area of the deck. Keep in mind, the deck surface can only be as smooth as the rail the finishing machine is riding on. Terex Bidwell recommends the 6 S's for setup of their finishing machines. The contractor is responsible for the setup of the machine, but observations and suggestions can be made by the inspection staff. Square the legs. The purpose of this step is to ensure the carriage rails are parallel to the proposed deck surface. Assuming the formwork on each side of the deck is the same height, all 4 legs should be adjusted to the same height when measuring from the screed pipe to the top of the carriage rail. Check with measurements to ensure all 4 legs are the same height. One of the 4 legs should also be locked to the truss to prevent any unwanted lateral movement on the truss section. Caution should be made to ensure only one leg is locked, as this will allow the other legs to flex without walking off the screed pipe. 2. Straighten the truss. All crown should be removed from the truss frame if using the crown bolts. The carriage should be positioned in the middle to maximize the deflection in the truss. The measurement between truss sections should be equal at the top and bottom. 3. String line the carriage rail. A string line should be stretched across the machine to ensure the carriage rail is perfectly straight. The carriage rail should be adjusted up or down as needed. Adjustments are made by rotating the carriage rail adjustment bolts either in or out to properly position the rail. Each bolt allows a maximum of 4.5 inches of travel for adjustment. The goal is to ensure that each measurement is consistent along the length of the carriage rail. Double check after tightening nuts. 4. String line the rollers. At this point, the leading and trailing ends should all be the same elevation when measuring down from the carriage rails. The rollers are adjusted by using the bolts holding the roller bearings in place. Work around the machine at least 3 times. Be fussy and write it down. 5. Set the crown and shoulder brakes if required. Adjust the crown by adjusting the crown bolts until the required cross slope is achieved. Shoulder brakes can be adjusted by moving the carriage rail adjustment screws. When performing a carriage rail adjustment, it is important to note that only about 2 to 4% change in slope, depending on the length, can be achieved by adjusting the carriage rail. This is due to the length of travel in the carriage adjustment screws. Any changes greater than 2 to 4% will require another truss section with a crown adjustment located at the breakpoint. This photo illustrates where an additional truss section was added. 6. Set to grade. Move the carriage to a place where the rollers are over top of a bulkhead or other fixed elevation. Using the leg cranks, lower the rollers so that they are just slightly above the bulkhead. Move the carriage along the bulkhead from one side to the other. When satisfied that the grade of the rollers is correct, measure and record the leg heights from the screed pipe to the carriage rail. Once the finishing machine has been set up and the contractor has completed all necessary rebar adjustments, you are ready for the dry run. The dry run is intended as the last-minute preparations prior to pouring the bridge deck. Everything should be considered during the dry run, not just rebar clearances and total depth of concrete. For example, at this point, a sufficient quantity of burlap should already be soaking, since it's required to soak for a minimum of 48 hours prior to placement. Prior to starting, the finishing machine truss should be loaded in the same manner that it will be during the placement. Gas and water tanks should be full. Generators and lighting devices should be present, and only the operator should be on the machine. This will ensure that the deflection in the truss during the dry run matches the deflection during the placement. Permanent station markings should be placed on the vertical edge formwork to be used as reference points during the concrete placement operation. To start the dry run, the leading edge of the rollers should be placed over a fixed, known elevation, like the bulkheads. The leading edge of the rollers should clear the bulkhead by 1/8 to 1/4 inch at all locations along the bulkhead. All bulkheads or expansion dams should be checked for clearances. If problems exist for clearances on the bulkheads, the legs should be equally raised or lowered to properly clear the bulkheads. After clearing the bulkheads, a straight edge is attached to the rollers to facilitate obtaining the dry run cover and depth measurements. The inspection measurements must be entered directly into an approved source document, similar to the one shown here, and be included in the permanent project records. Measurements will be taken over each pan, gutter line, and break point at longitudinal intervals not exceeding 10 feet along the length of the bridge deck. Record all total dry depth and cover measurements directly into the source document. Reinforcing steel deviating from the cover requirements by more than 1/4 inch must be corrected and rechecked. During the actual concrete placement, the wet depth check should be documented and compared to the measurements obtained during the dry run. The dry run should also include a check of finishing machine operation. Operate the finishing machine in production mode to ensure the reversing mechanisms are changing the direction as intended. The finishing machine should be timed to ensure it will finish the surface fast enough to meet the minimum specification longitudinal placement rate of 20 linear feet per hour. The unit should advance from 3 to 6 inches for each carriage pass. The transverse carriage travel speed can be increased or decreased depending on how the surface is being finished. A slower carriage travel speed will allow the paving rollers to have longer contact with the surface. A common starting point for carriage travel speed is approximately 60 feet per minute. The trailing end of the rollers should be approximately 1/8 inch higher than the leading end. This is accomplished by turning the rear leg cranks 1/2 turn counterclockwise. Document the leg heights again at this point as a check for any unwanted tampering of the equipment prior to releasing the concrete. While facing the machine, the clockwise auger should be in the right-hand shaft and the counterclockwise auger should be in the left-hand shaft. The augers should be initially set approximately 1/4 inch higher than the rollers. This adjustment is typically fine-tuned after the placement starts. The augers will form an imaginary V when installed correctly. The finishing machine must apply vibration to the plastic deck surface through a separate attachment from the machine manufacturer or by other means approved by the representative. Install and adjust attachments according to the manufacturer's recommendations. In advance of the deck placement, check systems to ensure proper operation. The drag pan and burlap drag H-frame should be mounted 5 to 7 inches above the finished surface. If the H-frame is too high or the chains are hooked too high, the pan will tend to hop as it is being dragged across the deck. The fogging equipment should be checked for proper operation. Nozzles should be pointed up, and the entire area behind the finishing equipment should be fogged. The nozzles should produce a fog and not spray or leak on the concrete. Water should never be sprayed directly onto the surface of the concrete. Before the actual deck placement, it is important to make sure all necessary equipment and tools are available. This includes all concrete testing supplies, 10-foot long-handled straight edge, floats, rakes, shovels, vibrators, evaporation rate monitor, and tining rake if applicable. Also, any needed lighting and generators should be checked, and a concrete cleanout facility for trucks should be available. Materials for curing should be on hand, such as intermediate curing compound, an adequate supply of water, pre-soaked burlap, soaker hoses, and polyethylene sheeting. Plastic should be on hand in case of any unforeseen rain. When the forecasted low temperatures are to be between 35 and 50 degrees at any time during the entire curing period, cool weather curing materials must be placed in addition to the normal curing materials. Blankets and polyethylene sheeting must be on hand to be placed on the deck. When the forecasted low temperatures are to be less than 35 degrees at any time during the entire curing period, the underside of the deck must also be enclosed and preheated prior to placing concrete. Heating can be accomplished by circulating hot water through lines placed under the deck, or by placing a series of heaters inside the enclosure. Other items to consider are the concrete pump or telebelt location and reach capabilities, along with any needed traffic control accommodations for the concrete delivery trucks. Concrete should not be released until the pump or telebelt is on site. Also, there should be a backup plan with equipment on hand in case of a breakdown. Final rebar touch-up should be performed on the day prior to the deck pour. All damaged epoxy coatings should be repaired with an approved 2-part epoxy touch-up kit. A final cleaning of the deck should also be performed the day prior to the deck placement to remove all mud, dirt, sawdust, tie wires, etc. Vacuuming or pressure washing are acceptable methods for cleaning. Measures should also be taken to avoid tracking dirt and debris from the approaches onto the deck. Getting a quality bridge deck takes considerable upfront effort. Good planning, active communication, and attention to detail will help to ensure a smooth placement and a quality bridge.